welcome back to another Leetcode video. Today we're going to be solving 229. Majority elements. Medium. Given an integer array of size n, find all elements that appear more than 1/3 times, right? So, if you haven't watched my last video, you should go ahead and watch it. The second problem I solve is actually something that uses the algorithm you're going to use today. So it'll be easier to understand. So let's look at the examples. Here, 3. Here, 1. And then here, they're both 50-50, right? So right off the bat, we can see that the max number of elements that we can return is only 2, right? Because if we were to divide something into 3, right? So let's say 1, 1, 2, 2, 4, 4. 4, 4. So it says more, right? So this not more, this not more, this not more. So we return 0, right? But let's say it's 1, 1, 1, 2, 2, 4, 4, right? Here, this is a kind of an odd number, but basically here we would only return this because this is more than 1/3, right? So we can't return just if it's 1/3, right? So what we're gonna use, so they can only be 2 more than 1/3 in a array basically. So like last time, we're gonna use where is it? Yeah, Moore's voting algo, right? So basically what this states is that if you were to count all elements, the majority element after one iteration would be the element, the element on top. I'll just show you guys. So here, I'll do it for 1. So it's E1, that would be element 1 is equal to 0, and the count C1 is equal to 0, right? So what this states is for I and nums, if count 1 equals 0, so it's kind of greedy, I guess. E1 equals I, C1 equals 1. And then it's like, so if the count is 0, then we would get a new one, right? And then so if the count is not 0, right? Or if the current element is equal to the, if E1 is equal to I, so we just do if elif E1 equal I, and then we would just increment the count, right? Because we've seen it again. And then so if it's not, then we just decrement count. C1. So I don't really want to run it, but basically at the end of this, E1 would be the majority element. So actually I will run it. I'll just print it. Okay, I'll just return an empty array. See? See, this one had 2, but this is still a majority element anyways. So we're going to use this theory to make 2. So we'll do E2, because we have to count 2, right? And then C2. So this is basically just an iteration of what we just did, right? So we want to get the two most occurring numbers, right? So what we're going to do is we're just going to do the same thing. So we would do if C1 equals 0, right? But we also want to check and I doesn't equal E2, right? Because I want to count them separately. So we would do E1 equals I, C1 equals 1, right? Because we just seen it. And then now we would do the same thing for C2, E1, E2, E2 C2, right? So now we would do the if it's equal. So we could do. Can we do elif? Okay, yeah. And then we would do if I'll just do if. I'll do I think yeah, I'll just do elif. And then so we would just do the other part, right? So elif I alright, we do e1 equals I, and I think that's about it. C1 plus equal 1. I think we just do if e2 equal I. Oh. C2 plus equal 1. And then just else C1 minus equal 1, C2 minus equal 1. And I think these can just be elif. Alright, so now let's just print it. And we'll just return the empty array still. So this is like two highest, right? These are the, well, this is because we initialized it 0, but yeah. I mean, if we look at the constraints, right? So it's not even, no, never mind, but yeah. And then case 2, these are the two highest, right? So we do have the two highest. Now, one thing we need to check is if they are 1/3. So we do t equals len n. Is it n or nums? Yeah, nums. Divided by 3, right? As the constraints. And then we would do like for I and nums. And let's just reset, just because we have to count the occurrences of each one. So we'll just do that. So we'll do if I equals e1, c1 plus equals 1, elif I equal e2, c2 plus equal 1. And then now we just have to check and append. So we'll call something here final equals this. If c1 greater than t, final dot append e1. If c2 greater than t, final dot append e2, and then we return final. So this is pretty long. I mean, pretty long and skinny, but this should work. Yep. And we submit it. And yeah, it's pretty fast, I'm pretty sure. Okay, let's see what he did. Return. Oh yeah, they opened it. Okay, well, this has been Moore's voting algorithm. Make sure to like and subscribe. Comment down below what you want to see next, and I'll see you guys tomorrow. Later.